So this library is used for numerical computation. So we are going to use this in Google Colab to execute some of the programs that shows you capability of NumPy. So let's create a code block, and to call for NumPy we simply use import NumPy as np. Right now, next thing is we will create an array and convert that into NumPy array. To do that, let's see if we create 2, 4, 6 and 8 as our array, and we print out np.array and pass our array to that. Right, so basically it will convert the array into NumPy array and output it. It won't be any different from our default array, but once we convert our regular array into NumPy array, it will be open for manipulating with the help of NumPy. Now let's print this out. As you can see, our array is printed. Now next thing is also doing the same for, let's say, multi-dimensional array. So multi-array, and within this we create 1, 2, then say 3, 4 and 5, 6. Right, now if we print it out with same np array and multi-array, so multi-dimensional array, the output should be like this: 1, 2, 3, 4, 5, 6. Right, now that was for multi-dimensional array being taken into our NumPy array. Now next thing we will take a look at is printing set of zeros and ones. So NumPy has that option with np dot zeros, and let's say I want total 4 within my array, so I can do that, and as you can see, 4 zeros. Similarly, I can also print out np, then ones, again 4. You don't have to go with 4 specifically, you can go with 6, 8, 2, 3 depending on your needs. And here see 4 zeros, 4 ones. So that was for your single dimensional array. What if you want to go with multidimensional? So let's say 4 by 5 for both 1 and 0, we can do that. Right, now in case of multidimensional array, what you have to do is add one more bracket, and let's say 4 by 5. If I have to do that for zeros as well and ones, I can do that. Now in case of multidimensional array, as you can see, I have kept 4 by 5 within a bracket. Right, so for both zeros and ones I have done that. So 4 by 5 matrix, and here basically I have added that within bracket. Right, so that was for our ones and zeros for both single dimensional and multidimensional. Now there is one more thing that you can do is let's say identity matrix. So basically it is the matrix which is for, let's say, a diagonal value of 1, but rest of the matrix has 0 within it. So I will show you how that goes. So print np, then I, and then let's say 5, and let's print this out, and here you see the diagonal value remains 1, rest of the values remain 0. Right, now that's for identity matrix. Now what about Linspace function? So basically Linspace function or method is that generates the evenly spaced point between numbers. Right, so in case of here, like I shown you the distance between the 2 points, I want for evenly spaced, let's say with 0 to 10 with the spacing of 3. I can do so by typing in print and then np linspace, and within that method I will pass in 0, 10 and spacing of 3, right? And if I run this, it should show me output of 0, 5, 10, right? So here you see the first and second parameter is basically starting and ending, while the third parameter is showing the distance between, or you can see the Linspace that between the numbers. So 0, 5, 10 pretty much evenly spaces it out, right? So you can try it for even bigger range. So let's say where you see basically if you want to do it for 20, right, range of 20 points, and I want it with total 20, then it should take me to not value point not, right? So if I do that, as you can see, it start from 0 to 10 and total spacing done is 20. All those 20 values are listed here, right? So you can go with 2, 3 up to 20 or higher. Then this Linspace will try to you can say add the spacing between these two numbers within the fraction amount that is coming out, right? So now that we know this, we will also take a look at some of the other functions, like let's say random numbers. So to do that, let's take a look at print np dot, let's say random, and then our function that has a parameter for 10, right? So if I run this, it should show me the random value with total 10 values, right? So in matrix we get that as output, right? So this was for single dimension. If you choose to get it for, let's say, 4 by 4 matrix, let's see, multidimensional should be different, and here you see 4 by 4 matrix with your random data, right? So after this, we can also take a look at how we can shape the array. So to do that, what we will do is we will first create an array. Instead of creating manually, we can also use np, then random, and then function that takes multidimensional 2 by 2, right, and shows us random data, right? So here we have to first print this out, right? So arr, and here you see 2 by 2, and then if I want to shape this, I will just call for arr shape, right, and then hit enter. As you can see, it will also tell you the shape 2 by 2, right? Now you can also use a reshape function. So to reshape, what we will do is we will try to print this with arr dot reshape, and then we will have to give it some multidimensional value, let's say 1 by 4. Let's see what it shows. As you can see, now it is showing me 1 by 4, right? So that's for shape and reshape. Now let's take a look at few operations with NumPy. So let's say if you want to find out discrete difference, what you can do is, let's say you create an array and call for np array, and where you take this particular array of value 10, 15, 25, 5, right? So next thing we will do is we will create another array. Let's name this array 2, then np dot difference with our previous array, right? And we will just output this array 2, right? So it should output the difference, which is the 10 to 5 difference 5, then 15 to 25 10, then from 25 to dropping to 5, which is minus 20. So such discrete difference can be found out using .diff method and passing on your numpy array. Right, now let's take a look at a few more operations, something like lowest common multiplier or greatest common denominator. So starting with LCM, let's say my number 1 is 4, number 2 is 6. Now my value for x equals np dot LCM, which is num1 num2, right? And if I print it out, that would be printing the value of x. So if I run this, it should show you the LCM of 12 for these two, right? So another thing that we can do is GCD. Now what is GCD? So GCD is basically greatest common denominator, right? So let's say if you have number 1 is set to 6, number 2 set to 9. Now instead of np.lcm, we'll replace this with np.gcd and then pass on num1 num2, right? And then simply run this code. And here you see the GCD between these two numbers is basically number 3, right? Now we can do this for an array as well. We can do this for both LCM and GCD. So let's say in case of LCM we have value of x, but here before that we will just create an array, right? So np dot array, and then inside this we'll have 3 6 9, right? And then x equals to, let's say, np dot LCM dot reduce, and then basically you are reducing to our array, and then finally print it out value of x. So let's take a look at the output. Is 18. Similarly we can do the same for GCD, and for that we'll have an array, and this time let's remove this, and within array what we will have is, let's say, 25, then 32, then let's say 36 and 16, right? Once we have that, x equals np dot gcd dot reduce for our array value and print out the x. If I run this, it should output the value of that particular GCD for this particular array, right? So we have seen the discrete difference, LCM and GCD. Now let's take a look at some of the trigonometric functions in NumPy. So we are going to take a look at functions like sine, cos, tan, which are trigonometric typical functions that you can use with your program. So let's say if I create a variable x and offered it np.sine, so which is going to be a sine function, and then let's say if I want to find out value of np.pi divided by 2, and then that value's sine value will be calculated, and then it will be printed, right? So let's run, and here you see value of 1. So pi by 2 and pi by 2's sine value, and then print of that particular value, right? Similarly you can replace this with cos, tan if you want, and get the respective values. So basically those functions are available to you as well. Now what if you want to find angle, right? So for that angle we will also have some of the functions such as arc sine, arc cos, arc tan. So let's say x, then np, then arc sine. If you want, take cos or tan, right? So we will go with sine, right? Now here what I will do is I will get 1.0's value, right, and then print it out. So let's see what it shows. It should show me the angle of 1.5 for that, right? Similarly, you can also get it for cos and tan as well. Now let's say, apart from these typical angles, sine, cos, tan, what if you want to find hypotenuse, right? So you need base and perpendicular value to find that. So let's have that. So base is 3 and perpendicular value 4, right? Now x should take np dot hypotenuse function and then take base and perp value, right? So base and perpendicular value, and print it out, value of x. If I run this, it should output value of 5, right? So you get the idea how to work with your sine, cos, tan functions, or you can also use arc sine, cos, tan for finding angle. Similarly, to find hypotenuse, you can use hypot function, right? Now let's take a look at distributions using NumPy library. So if you're from data science background, then you know distributions like normal, binomial, Poisson, and uniform. So let's take a look at each of them. So let's say if I create a variable and call for random dot normal. Now within this function, what we will do is we'll pass in a size of 2 by 3. So basically this normal distribution will be used for probability distribution of every event, like let's say heartbeat or so. So let's see what it outputs. X. So let's see. Okay, so here I made the mistake. The thing should be, let's say, np dot random, right? And let's run this, and here you see the normal distribution for size 2 by 3. Now similarly, binomial distribution is for outcome of binary scenarios. So to work with that, what we'll do, we'll create variable x, then np dot random dot binomial, and then we pass on a size in 10, then p equals to 0.5, and then size of 10, right? Now if we print this out and run this, we get our binomial distribution, right? So let's say next is Poisson's distribution, which shows how many times that event may happen in specified time. So to work with that, call for np dot random dot Poisson, and we have to pass on some values. So let's say first value will be lamb set to something like 2, and size, let's say 10. You'll also find what each of that means when you type in the parameters, and it shows you what each of that parameter is. So lamb is float or array like floats, where your size is in tuple, which is going to be integer. So as you can see, 2 and 10. Now let's print this one out. Let's print this out, and here see our Poisson distribution is here. Now there is also one more, which is uniform distribution. So np dot random dot uniform, and within that bracket we simply pass on the size. So size takes 2 by 3, right? And then print x. Now let's run this, and it should show you the uniform distribution value. So it's used in events where every event has equal chance of happening or occurring. So this is our uniform distribution. So we have seen up to 4 distributions here that we can do with NumPy.